Okay, I'm going to go through the data response question now. So the trick with data response is to always make sure that you are indeed reading the questions really carefully. So white clover is native to Eurasia, but is now a common plant found worldwide in lawns next to roads, pastures, and similar habitats. So that's what white clover is, just there. So then it goes on to say some plants are able to produce the toxin, hydrogen cyanide, by cyanogenesis. Now, that may not be a word that you've ever come across, but it doesn't really matter. You just need to know that that means cyano making, cyano is the hydrogen cyanide, genesis making. So a study at 128 sites with 2,509 plants in Toronto looked at the proportion of T. repens plants producing HCN. The sites were at regular intervals from the city centre to the rural areas. So I always say it's a good idea to try and read the graph. So looking at this graph, what you can see is there's a kind of, it's quite disparate data, but as you move away from the city centre, the proportion of plants with HCN seems to be increasing. Okay, so let's go on. So it says, for the first one, state, so you just need to give a number, the distance from the city centre at which the highest proportion of plants sampled contained HCN. Okay, so that's that point there. Okay, so you then need to draw a line down from here. Okay, and you can see it's coming between 30 and 40. Now, what you should actually do here is you should A, make sure that that line is straight, because mine isn't, and B, you should measure the distance between 30 and 40 to get a finer scale. Now, the mark scheme gave between 31 to 33. That was the range that is allowed. The answer it wanted was 32, and the units was kilometres. Okay, so then B, outline the relationship shown in the graph. So that's just a really quick, straightforward one. What's the relationship? So it's a correlation, and it's a positive correlation. So that's what you're looking for there. We'd already worked that out just through reading the graph. Okay, so now we're going to look at some other cities. So we've got New York City, we've got Boston, and we've got Montreal. So if you look at New York City, you can see there's also a positive correlation. In Boston, there's also a positive correlation, whereas in Montreal, it seems to be a more negative correlation. So deduce whether a pattern of cyanogenesis was the same in all areas around all 4 cities for 2 marks. Okay, so deduce, that's going to mean using the data to help you to come up with an answer. So is the pattern the same? So you could say that Toronto and New York and Boston, they showed the same pattern, which is a positive correlation. Okay, so that would be 1 point. And then you could say that Montreal showed a different pattern, which is a negative correlation. Okay, so that will give you your 2 marks, because you've identified the areas where it's the same, and you've identified the areas where it's different. So then we go on, that gives you some more information. So the research considered 2 possible ecological causes for the observed gradients in cyanogenesis. First, the researchers assessed the extent of herbivory of the T. repens plants in Toronto by measuring the percentage of leaf area that was eaten. The graph shows the results for both cyanogenic and non-cyanogenic plants. So again, let's have a look and see if we can work out what's going on. So can we see a difference here? Can we see that the non-cyanogenic plants are being eaten more than the cyanogenic plants? Well, maybe. You do seem to have a few more of the triangles than you do of the spots in the upper area. And does that change over time? There a little bit maybe, but not a huge amount. So what's the question then saying? Discuss whether the data supports the hypothesis that the gradient in cyanogenesis is due to its benefits against herbivory in rural areas. So The rural areas would be these ones with greater distance from the city. So if you look at the trend lines, there's not really any difference between them. So you would need to say that the hypothesis was not supported. Okay, so that would be your starting point. Again, it's 2 marks that you've got to make here. And so then you'd want to say, well, why? Well, actually, if you look at the difference there and compare it with the difference there, the difference is actually smaller. So you could say there's a smaller difference in rural, sorry, my handwriting is awful today, and non-rural. Okay, that could be a point you could make. You could say that there's just a lot of overlap between the cyanogenic and the non-cyanogenic where it comes to the herbivory results. Like, it's difficult to see a clear trend sort of anywhere in this graph. And you can say that both show a negative correlation. So, I mean, those are the sorts of things. Now, if you wanted to say that there was some support in this, it would be, you could say it was partly supported by, there's a lower herbivory rate in cyanogenic plants in all areas because the spots are in this lower zone here as opposed to this upper zone here. But it's probably easier to say it isn't supported because it isn't really. Okay, so now we've got a new graph. So the researchers then investigated a possible correlation between cyanogenesis and exposure to freezing conditions. Been proposed that when a cyanogenic plant freezes, its cells burst, releasing hydrogen cyanide, which is toxic to the plant. Snow can insulate the ground and plants from freezing temperatures. However, snow is more likely to melt in cities, which then exposes plants to freezing temperatures. All 4 cities studied below received freezing temperatures and winter snowfall. Researchers looked at the numbers of days below freezing that did not have snow cover in these cities. So Toronto, New York and Boston had the most, and Montreal had the least. So identify with a reason the city where the plants were more insulated from freezing temperatures. So the place where you're going to have the most insulation is where there is the most snow. So you're looking for the lowest number here, which is Montreal. Okay, so then using all of the data so far, suggest whether exposure to freezing temperatures in the 4 cities is supported as a reason for the difference in hydrogen cyanide production in clover. So you can see that these 3 cities have the lower amount of, the higher amount without snow cover, so greatest exposure to freezing conditions, and those were the ones with the negative correlation, the positive correlation. So you could say that cities with the without the snow cover have a positive correlation between the distance from the city centre and HCN, whereas for Montreal, you've got much more snow cover and a negative correlation. So you could say that though in Toronto, New York and Boston, you've got more days without snow cover, so more exposed to freezing temperatures, which is different from Montreal. So those ones with more days without snow cover proportion are going to perhaps have more of this freezing and bursting and brain and then the hydrogen cyanide killing the plant. So that would suggest that the hypothesis is supported. And that is your data response question.